Hello dear students, in last few lectures we have covered the binary number system, hexadecimal number system and the octal number system. In this video we will be learning decimal number system to any other system conversion. Okay, so here we are going to convert decimal number to binary number, decimal number to hexadecimal number and decimal number to octal number. Okay, why I am taking these three things in the same video? Because the process or the steps are quite similar. Okay, only the difference is that while converting the decimal number into binary, we keep on dividing that decimal number by 2, because power of the base of the binary number system is 2. While converting decimal number into octal, we keep on dividing the decimal number by 8, because for the octal number system the base is 8. And for hexadecimal number, we take help of 16. For the hexadecimal number, base is 16. Okay. So decimal number, for example, any decimal number, for example 48. This number, if I want to convert this number, this will be a quite big string. Okay. So I will take a smaller number comparatively, 32. Okay. 32, this is a decimal number. If I want binary equivalent for this, so I will take 32 and I will keep on dividing this number by 2. Quotient part I will write here, remainder part I will write here. Okay, this part I have covered in my decimal to in binary number system video. So if I divide this number 32, so I will get quotient 16, remainder will be 0. Then 2 8s are 16, again remainder will be 0. 2 4s are 8, quotient will be 4, remainder will be 0. 2 2s are 4, remainder will be 0. 2 1s are 2, remainder will be 0. And we know that we have to keep on dividing the number until we get the quotient 1, because 1 cannot get divided by 2. I have to shift this here. Okay, now the important step, last step, is we have to go from bottom to top. We have to follow this sequence. So 1 0 0 0 0 0, this will be the binary string for this decimal number, or this will be the binary equivalent for the decimal number 32. 1 1 2 3 4 5 zeros. Okay, so this is binary equivalent for this decimal number. Okay, now if I take the second number system, for example, if I want to, again I will take for example 48. This number I am taking, this is decimal number, I want the octal equivalent for this number. Okay, so for that what I will do is, process, the steps are same, but here only we have to keep on dividing this number by 8, because the base is 8 for the octal number. 8 6 are 48. Okay, so I will be writing 8 6 are 48, remainder I have to write here, so it will be, remainder will be 0. Now directly I am getting 6 here, so it cannot be divided by 8, so I have to shift it here. Okay, if the number is bigger, so we have to keep on dividing the number and we have to keep on writing the remainder here and quotient here. So I cannot divide this number by 8, so I have to shift it here. Okay, so 6 0, again bottom to top, 6 0. So this is the binary, this is the octal equivalent for this decimal number. Right, now this way we can convert any decimal number into octal. This is the decimal number, I want binary equivalent for this, hexadecimal equivalent for this. The processes, steps are same, but here in this case we have to divide this number by 16. Okay, so 16, quotient here, remainder here, 16 4s are 64. Okay, so 16 4s are 64, and what will be the remainder then? 14. The remainder will be 14. Okay, so you have to write remainder here. Now 4, again it cannot be divided by, it cannot get divided by 16, so I will write, I have to shift it here. Okay, so now bottom to top. But here in this case one more step is there, because for 14 we can represent this number in hexadecimal by E letter, right? If here it is 10, so I don't write 10 here, I have to write A. For 11 I have to write B, and so on. 15 I have to write F. Okay, I cannot get 16 here, because if remainder is 16, so we don't write remainder here, it would have got divided by 16 then. Okay, so maximum number which I can get here is 15 only. Okay, so for 15 I will be having F, I can write F there. So 4E, so 4E will be the hexadecimal equivalent for this decimal number. Okay, so in this video I think the things are clear to you. We can convert any decimal number into any other number system by just keeping on dividing that decimal number by the base of that particular number system in which we want to convert the decimal number. Okay.